Imagine walking up to a wall, running straight at it, and disappearing, only to reappear on the other side, completely unharmed. Sounds impossible, right? For you, it is. But for the quantum world, it happens all the time. This bizarre behavior is called quantum tunneling, and it's not just a freak accident. It's a real, measurable, essential phenomenon that underpins everything from nuclear fusion in stars to the device you're watching this on right now. Let's explore how particles break through walls and why this seemingly magical trick might hold the key to future technologies and even the origin of life. In our everyday world, if a ball doesn't have enough energy to roll over a hill, it stops. No exceptions. But in the quantum world, particles like electrons don't behave like tiny balls. They behave more like probability clouds. You can't point to exactly where they are, only where they're likely to be. And those probabilities? They're governed by the Schrödinger equation, the heart of quantum mechanics. Now here's the kicker. Even if a particle shouldn't have enough energy to cross a barrier, the math says there's still a small, but non-zero chance that it could just appear on the other side. That's quantum tunneling. Imagine a hill and a ball. Classically, the ball needs enough energy to reach the top. But in quantum mechanics, the ball is a wave. That wave spreads out. It's not confined to one place. When that wave reaches a wall or barrier, some of it gets reflected, but some of it leaks through. If the wall is thin enough or the wave strong enough, part of the wave can appear on the other side, and so can the particle. It's not that the particle punches a hole in the wall. It's more like the particle's existence smears into the forbidden zone, and occasionally that smear is enough to actually place it on the other side. It doesn't break the laws of physics, it follows them perfectly. They're just not the laws you're used to. Okay, this sounds weird, but so what? Does this ever actually happen? Yes, and it's vital to how the universe works. Let's start big. The sun only shines because of quantum tunneling. Inside the sun's core, hydrogen atoms are trying to fuse into helium. But they're positively charged, and like charges repel. Under normal conditions, they shouldn't get close enough to fuse. But quantum tunneling lets them slip through their mutual repulsion just often enough for fusion to happen. No tunneling, no fusion, no light, no stars, no life. Then there's radioactive decay. Some unstable nuclei emit particles that again don't seem to have enough energy to escape. But thanks to tunneling, they do. That's how alpha particles escape from heavy atoms like uranium. Even your smartphone owes tunneling a debt. Flash memory relies on a process called quantum tunneling to store and erase data. Your selfies exist thanks to quantum weirdness. Scientists are now trying to harness tunneling for futuristic technologies. One big example, quantum tunneling microscopes. These can map individual atoms on surfaces by detecting electrons that tunnel between a needle and the material. But even more exciting are tunnel diodes and next-gen transistors that use tunneling to switch states faster and more efficiently than anything in traditional silicon chips. We're also exploring quantum tunneling in biology. Some researchers think tunneling plays a role in enzymes, speeding up reactions by letting particles tunnel into new molecular configurations. And some radical theories even suggest that tunneling could have helped spark the origin of life, allowing prebiotic molecules to explore complex chemical spaces much faster than classical physics would allow. So could a human ever tunnel through a wall? Nope, sorry. The probability of all the particles in your body tunneling in exactly the right way is essentially zero. The odds are so low that the universe would die of heat death long before it happened even once. But at the quantum scale, particles tunnel all the time. In fact, they must, or reality as we know it wouldn't exist. It's a reminder that nature doesn't always play by the rules we see. It plays by rules we discover, one experiment at a time. Conclusion: reality leaks. Quantum tunneling is a perfect example of what makes science beautiful. It challenges our assumptions, defies our intuitions, and yet powers the stars, our devices, and maybe even life itself. The next time someone tells you something is impossible, remember, in the quantum world, even walls can be optional. Thanks for tunneling through this topic with me. If you want more mind-bending science explained in a way that's fun and clear, hit that subscribe button. And if you've got a quantum question or a theory about tunneling we didn't cover, drop it in the comments. Until next time, stay curious and remember, reality is stranger than fiction, especially when quantum mechanics gets involved.